Hi friends, our today's session is on linear programming model. Here I have mentioned three components which are used in LPP model. First one is decision variables or activities, and all decision variables are x1, x2 up to xn, and these should be greater than or equal to 0. Here I have mentioned one example that is related to product mix, and second one is objective function that could be maximize or minimize in both cases. Third one is constraints. Here constraints will be labor, machine, raw material, etc. And such constraints must be expressed as a linear inequalities in terms of decision variables. There are certain requirements in industries to meet their goals. First one is objective. This should be measurable or identifiable. Each and every resources should be allocated to the persons or users. There are some limitations of resources and there are some alternative decisions for their resources. Here some assumptions which are used in linear programming model. Here we have to identify some certainty for the business, some continuity in business, additivity. Here I have mentioned one example. Suppose you are manufacturing two products, then how to use this additivity that I have mentioned here. Fourth one is linearity or proportionality between the objective function and constraints. Each and every condition will get satisfied. Here I have mentioned example for this. Suppose if production of one unit of product uses 5 hours of a particular resource, then making 3 units of that products uses 3 into 5. That is equal to 15 hours of that resource. There are many advantages of linear programming model. Here I have enlisted some advantages. Here industry is trying to, or everybody is trying to find out optimum solution to their resources, to their organization, to their decision making. Here second one is decision making for productive factors. Then it will improve the quality of decisions. It is helpful for decision making or taking. Bottleneck can be reduced by using this linear programming model. Here I have mentioned many applications of linear programming model. First one is agriculture application. Here I have mentioned specific application of agriculture. Here we can plan the allocations of resources for maximizing revenue or yield of the particular product. The second one, applications in military, production management, next financial management, marketing management, personal management. These are the major applications of linear programming, but there is no limitation for this particular subject. This LPP model can be used everywhere in a industry, any organization, or for small decision or bigger decision. Here I have added graphical solution. There are types of graphical solutions. Solution may be feasible, basic solution, basic feasible solution, optimum feasible solution, degenerate solution, and special cases in linear programming. Here I have mentioned a detailed definition of or meaning of each solution. First method is simplex method. It is initial method. Here I have mentioned the procedure for maximization case. First, formulate the problem. Here I have written some steps. First, translate the technical specification of the problems into inequalities. Inequalities will be given. Convert the inequalities into equalities by adding some slack variables or some other variables. According to that addition, we have to modify objective function as well. Second step, design an initial program. Calculate the net evaluation rows and test these rows are right according to the equations. Third step, revise the program. Find the key column, find the key row and the key number. These things we will see in problem. Optimize the optimal program or problem. How to optimize? Here we have to repeat steps 3 to 4 until a program has been obtained. Procedure for the simplex method. Here case is minimization case. Things are saved. Some changes I have mentioned in this. You can go through it. Next, fourth step, obtain the optimal program. Here same thing is given. Example will be given like this. This case may be maximization or minimization. Thank you.